Hello everyone and welcome to this session, and in today's session I'm going to talk about Wheatstone bridge and how do you balance the Wheatstone bridge. This is a class 12 topic of CBSE physics, and here when I talk about Wheatstone bridge, it is not any type of bridge that I see in top of a river. It is a Wheatstone bridge created with the help of 4 resistors connected in a particular pattern. So basically that's called as Wheatstone bridge, and there is a condition for balancing the Wheatstone bridge. So here I'm going to balance the Wheatstone bridge with the help of Kirchhoff's law. Okay, there are 2 Kirchhoff rules which I'm not going to discuss in this video, but I assume that you have the knowledge of Kirchhoff's law before you see this video. So let me go to that and I'll show you how are you going to balance a Wheatstone bridge. So let's begin. Let's go to the screen share and let's see. First of all, let me draw a Wheatstone bridge. Okay, and in a Wheatstone bridge, it's an arrangement of 4 resistors. You see, resistor number 1, resistor number 2. It's like a square kept in a vertical form. Resistor number 3, and I have another resistor here. And in between these 2 points, so I would call it A, B, I would call this point C and D. So you see here between B and D I have a galvanometer attached. Galvanometer, you know, galvanometer can measure my current value. When fixed in this form, it is going to measure my current value, and of course battery is being connected from this branch. From A and C there is a connection of battery given like this. Okay, A and C goes to the battery and the current flows. So I know my general rule that this is the total current I know this is the total current I. Yes, my total current. From point A, the current is going to be divided into 2 parts. One is going to be I1. Okay, so this is resistance P and this is Q. This is resistance S and this is resistance R. So I have 4 resistors and their names are here. Right, now you look what is going to happen. Let me show the current in the form of red color. So now in this branch AB, current I1 is going to flow. In this branch AD, I'm going to have I minus I1, isn't it? Because in that branch, if I1 is going, this branch is going to have I minus I1, right? If AB is getting I, just like a flow of water, see when the water flows into the tributaries, right? So what is going to happen? So tributaries, so some of the water is going to go this side, some of the water is going to go this side. So I1 has gone to AB, so the remaining I minus I1 is going to AD. Then from point B, there's going to be more tributaries. That means from I expect IG to go down. So between B and C, it's going to be I1 minus IG that is taking a flow. So that means from B, the current reduces more. And at the point S, IG is getting added. So between D and C, I minus I1 plus IG. So that IG that came from point B got added at point D, and finally through C both of them get added and current I comes out again. You see, you add I minus I1 plus IG plus I minus IG, you will get I. Why don't you just add it? I minus I1 plus IG plus, okay, and I'm going to have I minus I1 plus IG, alright, plus I1 minus IG. IG gets cancelled, I1 gets cancelled. My final answer is I. So current I is flowing through back from C. Alright, I have created my currents. Okay, I have not fixed basically, I have found out if I is the total current flowing, what are the distributions that are going to happen. Now you know what, there is something that needed to be done. If I want to balance this Wheatstone bridge, Okay, remember, if I want to balance the Wheatstone bridge, there should be no current flowing between B and D. Listen carefully. If I want to balance the Wheatstone bridge, there should be no current flowing between B and D. Technically, that means Ig should be 0. Ig should be 0. But when is this possible? This is only possible when the Wheatstone bridge is balanced. And there is a particular relationship between PQRS. So who decides this? Who decides that Ig should be 0? PQRS are going to decide that Ig should be 0. And they have a relationship. We are going to find that relationship in this derivation. So that's what I'm saying. Finding out if the Wheatstone bridge is balanced or not balanced. Let's move forward. Now I will be using Kirchhoff's law. Alright, so I'm going to use Kirchhoff's law and I'm going to apply it to ABDA. Okay, the first one. There are two loops. One loop I'm going to use ABDA. I'm going to apply Kirchhoff's law in ABDA. So let us try applying Kirchhoff's law in ABDA. So the direction of travel is very important, you know, right? The direction of travel, you remember the rules. So I'm going to travel like this now. Okay, so now look here, I'm going to travel like this. Let's see what is getting. Let's start from A. So first one is going to be I1 into P. Let me write it here. So when we are going the same direction as current, I can write I into R as positive. So first one is going to be I1 into P. Then we are going in the direction of Ig. So let's say that the resistance of G galvanometer is G. So it's going to be Ig into G. Now I'm going in the reverse direction. You see in the loop, I'm going in the reverse direction like this now against the current. So now it's going to be minus of I minus I1 into R. Okay, should be equal to the total EMF, and you very well know that in this particular loop the EMF is 0. There is no battery, there is no EMF source, so it's 0, right? Okay, let me go to the next. Okay, so this is my first loop. Which loop? ABDA. ABDA. Let me go to the next loop. That's going to be BCDB, right? BCDB. BCDB. I hope you're following this. BCDB. So in BCDB, I'm going to apply this rule. Okay, in BCDB, I'm going to apply this rule, and let me Kirchhoff's second rule I'm applying here, and let me see. So I'm going to start from here. My the path traveled will be this. Okay, let's try. So let me start from B, and it's going to be in the direction of current. So it's going to be I minus Ig into Q. Then now from C to D I'm going, but it is the reverse direction to the current. So it's going to be minus I minus I1. Okay, I minus I1. So it's already total. Okay, we should not do the mistake here, you know. I minus I1, I think it is plus G. I can add plus G also here, plus Ig. Okay, into S. Then I'm going in the DB direction, which is going to be negative Ig. Okay, negative Ig into G. Right. Now this is my second equation, right? Equal to 0, of course, equal to 0. This is my second equation, right? Now in this equation, it is made because of BCDB. Okay, it's made because of loop BCDB, right? So now what I'm going to do here, I told you I got two equations now. Okay, one is the loop ABDA, and I got equation number 1. Others for loop BCDB, and I got equation number 2, right? Now, if I want to find out the condition for balance, if I want to find out the condition for balancing, put Ig value 0. Okay, so what's my condition? My condition is Ig value should be 0. Just put Ig value 0 everywhere. So what happens to my first equation? My first equation becomes I1 into P minus I minus I1 into R equals 0, right? Then second equation, what happens to second equation? For second equation, Ig when it is 0, it's going to be I, okay? So this is going to be, 1 second, I1, yeah, it's going to be I minus, okay, I into Q minus, here I have I minus I1, okay, into S equals 0, right? I minus I1 to S equal 0. And here is a small error, it's I1 here, okay, into Q, I1, so this is also I1. So yeah, we have to be very careful in that situation. Now equation number 1 can be turned into this: I1 into P equal I minus I1 into R. Same way, equation number can be turned into, I'm just doing, changing the sides, that's all. I'm not doing anything big, I'm just changing the side here and there. Okay, so this is going to be I1 into Q equal I minus I1 into S. Now let me say this is equation A, this is equation B. So I am ending up getting two equations. So this is a final equation. So equation 1 and equation 2 have got modified into final equation A and B here. Okay, now what I'm going to do here is A divided by B. Okay, now when you divide A by B, it's going to be I1 into P divided by I1 into Q equal to I minus I1 into R divided by I minus I1 into S. I1 gets cancelled, I minus I1 gets cancelled. You have P by Q equal R by S. P by Q equal R by S. Can you see here? I have a very fundamental equation, P by Q equal R by S, or I can also write it as P by R equal Q by S. Both are same, there's not much difference. P by R is equal to Q by S. This is the condition for balancing, students. This is how I have balanced my Wheatstone bridge. This is the condition for balancing the Wheatstone bridge. So in a Wheatstone bridge, when P by Q is equal to R by S, now these values can be fixed. Okay, so I will just show you an example of how it is. Okay, I'll just give you an example of a balanced Wheatstone bridge. That's going to be like this. Let's have this as 4 ohms. And let me just draw the resistors here. I have a galvanometer which is going to measure the current at the center. So it can be 4, it can be 8, it can be 12, and it can be 24 ohms. Now look here. Now the question here is, if this is my Wheatstone bridge structure, will the current be balanced? Will the Wheatstone bridge be balanced? Yes, it will be balanced. How? 4 by 12 is equal to 8 by 24. Yes, it is. The ratio is same. So this is the condition for the Wheatstone bridge to be balanced. So this is how you identify Wheatstone bridge is balanced or no. So when Wheatstone bridge is balanced, you don't have to do anything to anything. Like, if I would say in this way, let's imagine in the place of G, if there is some other resistor. So in your calculation you need not include the resistor, because the current is not going there at all. The current is not going there at all. So like, if we have another example where in the place of G they give you another resistor, okay, they'll give you another resistor which is going to be 5 ohms, and they ask you what is the total resistance between the point A and B. What is the total resistance? So here you have to quickly analyze if it is a balanced Wheatstone bridge. And if it is a balanced Wheatstone bridge, your work is very simple, because 4 and 8 are in series, 12 and 24 are in series, and the combination of 4, 8 and the combination of 12, 24 are in parallel to each other, and you will be able to get your answer what is required without taking phi into consideration. You need not deal with phi. If at all it was not balanced, then you have to include phi also in the calculation, because current will flow through it. If the Wheatstone bridge is balanced, the current will not flow through phi. If the Wheatstone bridge is not balanced, the current will flow through phi. So this is the case, students. You should be knowing how to balance the Wheatstone bridge. So students, with this I will bring an end to my video. I hope you were able to understand this concept. My idea is to make complex concepts into very, very simple form, so that you can grasp and digest it. So with that, I will end my session now, and please do not forget to like, share and subscribe this video. We will see you in the next video. So until then, adios.